Let's go ahead and jump into part 3, endpoint security. Here's what we're going to be talking about. So when we talk about endpoint security, remember, we're talking about all endpoints. We're not just talking about laptops and desktops. We're talking about smartphones, IoT devices. We're talking about anything that is communicating over our network and is sending and receiving data over that network, all right? So all of these are important. You're going to hear me talk about IoT devices. You know, these devices, they're so simple in nature. They're so popular. They're being put out with unsecure software, right? So consequently, we have to secure that software and manage it just like we do with traditional endpoints like Windows clients or Mac, operating systems, for example, right? So again, critical for preventing unauthorized access, making sure user accounts, which we'll go into, are secure and that users are using the right user account for their job, okay? So, we deploy security software, we manage patches, we harden systems to a baseline, all of which we'll talk about in this lecture. So let's start with patch management. With patch management, it is, a systematic notification, identification, deployment, installment, verification. Man, that is a lot of stuff, right? So luckily there are tools to help us automate this. And in this lecture, we are going to dive in right at the end to CrowdStrike because it is an absolutely great and unfortunate example of just one patch wreaking havoc on 8.5 million computers. So what do we need to know about patch management? We need to know what a patch is. It's basically a software update that fixes a bug, it fixes a vulnerability, right? Without changing the overall version of the software. So, we have what's called Black Tuesday, the second Tuesday of every month. It's when Microsoft releases patches. The challenge is they tell us what was wrong with the system, which means we're also informing hackers on what vulnerabilities existed. Thus, if you're not patching right after that, these are legitimate vulnerabilities on your system. So we have to patch. We have to patch quickly. But as we'll see, we don't just throw patches out without testing and testing and testing again. So hot fixes are targeted updates released to address critical issues. So in the example of CrowdStrike, Microsoft releases a hotfix to help with resolving the issue to get these computers back up and running, as we'll see. Service packs are basically collections of these updates, these hot fixes, and sometimes additional patches, additional enhancements, again, without majorly changing whatever the application, the operating system, the software is. Okay, so one example is Microsoft Windows Software Update Services. Now, folks, if you're going to do this as a career, I cannot encourage you enough to utilize virtualization, as I said. Build your network at home, put everything on the network, manage it, look at Wireshark, look at where packets are going, practice this at home so that you're prepared to do it in the workforce. And a great example would be to get, the opportunity. Maybe you take some classes like at a community college like my students do. They get access to free Microsoft software. They can build their own servers, their Active Directory infrastructures. They can put their daily computer on there. They can deploy Windows software update services and start learning this. So system hardening is the process of, once we have a patch management system, we know it's running, it's doing its job, we have to harden the system. And that basically means removing any unnecessary services, applying those security patches, knowing those are getting applied, configuring system settings to enforce whatever the security policies are for that organization. Now, these can vary, right? But there are some things called baselines that we should know. And you can always go out and look for white papers from Microsoft, from security companies on what is a good default baseline, say for a Windows 11 Pro client operating system. So that endpoint, right? And how to create that. Because again, that wants to have, the limited number of services, the limited software applications, everything to a base limit so that we know it's secure. Then we can take that single image and deploy it across different departments, in which case we might need to add additional software. We might need to provide additional privileges or feature functionality, okay? In order to make, but again, we're not removing things, we are adding things. So we're coming up with a baseline, that minimum. Hugely important to have that baseline image to work with. So user accounts, there's another layer of endpoint security. We, again, and we discussed this previously really briefly, if you're an administrator, you have two accounts. You have an administrative account when you need to do administrative functions on databases, on servers, on whatever, on networks, on hardware such as firewalls, but daily operations are done with a standard user account, okay? So these user accounts, digital identities with, within a client or server operating system. So we can create multiple accounts on a client even if it's not connected to a network. Standard user accounts, that's the best practice. We've got limited privileges. We're not going to be able to install software. I like how Mac does this. Basically they have this limited privileges account, but when you install software, you have to give it your password again and authenticate again at a higher level for that software to install. So, wonderful thing there, right? Enhanced security helps prevent accidental or, malicious damage to the system. We don't want end users playing in the registry, for example. We don't want them installing software that's not approved by our organization, okay? Again, suitable for most users. So types of standard user accounts, personal accounts, okay, or standard account, limited account, guest accounts, managed accounts, that we can manage, say, over an Active Directory infrastructure, for example. I tend not to use guest accounts. I tend to create limited contractor accounts with limited access. And if they don't need access to my network, all they need is internet. I throw them on a guest Wi-Fi and they can work within our organization without being part of our network. So again, all of this comes down to the idea of zero trust, okay? Which again, we'll talk about in detail. So privileged user accounts, these are those accounts with approved authorizations at a privileged user level, meaning they can make changes, they can install software, they can configure system settings, they can play around in the registry, they can troubleshoot, files within the Windows operating system file structure, okay? And again, access sensitive data. So, what does that mean? It means protect the user account. Today, these administrative accounts should be multi-factor authentication accounts. So even if the credentials, right, are garnered by a hacker, they still need a second point of authentication in order to do that work, okay? In order to gain access, change systems, steal data, whatever the case may be. So critical system tasks, essential for maintaining and managing the overall system. Installing updates, removing patches, installing that Microsoft hotfix, for example. Enhancing security measures. Again, multi-factor authentication is huge. Regular auditing of these accounts is essential. We want to make sure that we know who's using accounts, what they're using these accounts for, because again, they have access. So remember, threat actors also reside inside our organization, and so we want to make sure to protect the organization overall, even from administrators with high trust levels. Software firewalls, let's be clear, all firewalls are software. It's just you might think of a hardware firewall like the one you buy, okay, that's a router, firewall, switch for your home. It has software that runs it, right? Normally a Linux distribution of some sort. However, software firewalls are built into endpoints. We see these in Windows Defender. Within NetFilter, we tend not to integrate right directly with NetFilter. We do those changes through IP table, firewalled, and uncomplicated firewalled, which probably should be a capital U. So we'll just change that and move on. So that does bring us to CrowdStrike. Let's talk CrowdStrike. Lots for us to learn here and unfortunately a great recent example. And that is, here is a cybersecurity technology company based in Austin, Texas. They provide cloud workload protection, endpoint security, threat intelligence, cybersecurity response services. You think they would know to test their software patches, but oh no! July 19th, they issue a patch to their Falcon sensor software, by the way, that runs on Windows PCs. So Linux PCs weren't affected. Mac wasn't affected at all. So, kind of interesting. So as we work through this, the incident, basically, they release a patch and it takes down 8.5 million computers that have to be restarted multiple times, sometimes up to, I think, 13 times, before you could actually get a login screen to log in and remove the vulnerable patch that caused the issue, right? So what happens? Fortune 500 companies lost 5.4 million. Delta Airlines reported 500 million. Now everybody's suing CrowdStrike, but let's be clear. CrowdStrike has a part in this, but as we're going to learn on the next screen, so do these companies that utilize the software. They are equally responsible, if not more, because ultimately they are responsible for their networks. Yes, there was reputation damage. The stock price of CrowdStrike fell up to 32% drop in 12 days, resulting in $25 billion of market value loss. Okay, and so this is going to reel, all by the way, because software wasn't effectively managed. As we can see, poor patch management, poor testing of the patches in a controlled environment. Rigorous testing must be done before we release this in the wild, because then we don't take down 8.5 million computing devices, right? But here's the thing. These companies should have had better incident response plans. They should have, the issue was delayed and uncoordinated responses. What do we do, right? It was literally within hours that Microsoft released a patch, and then so did CrowdStrike to fix the issue. But a lot of these systems like Delta were down for days and lost money, of which they're also responsible, as I'll detail here in a minute. First of all, what did that mean? It meant that they did not have a good business continuity and disaster recovery plan in place. And we're going to talk about those later in a separate chapter. But these are imperative, and these have to be practiced. We need to train people on these teams. Inadequate incident response training was definitely an issue, right? Ensure staff are well trained. Come up with scenarios. Create disasters, and then practice how you recover from those disasters. This shouldn't have been a disaster. How do we keep this from happening? It's pretty clear. We stage our patch management. I would never, unless it was an absolute, I can only remember one time years ago in getting a patch, I think it was for like the Melissa virus. It was just rampaging networks, right? And so we were like, we're going to patch this, and if the patch screws things up, we'll deal with it. In this case, you patch out to non-essential machines, even if you do that just for a few hours. If there's no cybersecurity attack that this patch is defending against, it's simple. This is common sense. You don't patch all of your systems. You patch non-critical systems. You monitor those systems. You do it in a test environment if you absolutely can. A virtual network environment. And which is hard to do with these big networks, let me be clear. But at that point, you throw these out to non-essential computers, and instantly you would know, wait a minute, these computers aren't rebooting. Stop the process, no more problem. That falls on Delta. That falls on those companies. That falls on the city of Portland, whose mayor pronounced like a disaster, because this took down vital services, such as law enforcement, etc. Okay, key takeaways? CrowdStrike, do a better job. I bet they never release another patch without thoroughly testing it, right? Learn from these challenges. Learn from mistakes of others. That's huge. You know, I always like to tell my students and share with them stories where I have made mistakes so that they don't have to make the same mistakes again. Finally, you know, here's what travelers ended up looking at in airports. You know, well, this airline seemed to figure it out, but these certainly didn't. You know, all of these systems going down at once, systems embedded inside systems, consequently, you know, systems for scheduling pilots, scheduling aircraft, you know, scheduling unexpected maintenance, all of it down because of one patch. So learn this lesson. Make sure you install those patches at a staged level on non-essential machines. See how they're running. See if they impact any of the unique software that you are required to run within your organization, and then finally deploy out to the rest of your computers. Folks, we will see you again for part 4 of 5 parts. In part 4, we are going to take a look at the basics, very basics of computer networking, the things you need to know for the ISC2 certified in cybersecurity, as well as start building a foundation of networking that you definitely, as a cybersecurity professional, are going to want to enhance by future instruction, future classes, future certifications on your way, and in my opinion, before your Security Plus exam, before you take that coveted Security Plus, you want to make sure to cover A Plus and Network Plus at a minimum. We'll see you in the next video. Take care.